just with any type of significance test, we need to meet certain conditions. So here we have the random condition, and then this is the one to test for normality. So are we normal? And this is our expected value at least 5. So we're going to talk about expected values in our example, but when I am dealing with categories, I should expect at least 5 whatever. In the example we're going to look at, or multiple choice answers, so I should expect at least 5 answers to be A, or at least 5 to be B, and so on and so forth. And then we need to test for independence just like we would normally do. So we'll take a look at the normal condition in our example so you get a better idea of what exactly does that mean. So I'm going to pause the video and I want you to think about how is the chi-squared distribution similar to the sampling distribution of sample mean. So I'm going to think about the central limit theorem and how this applies, specifically with the shape of the distribution. And then think about how is it different. And then lastly, try to restate how do we test for normality in a chi-squared distribution. There are 3 different types of chi-squared tests, each of which we'll talk about this week. And we're going to take a look at the second one on Thursday, and the last one on Friday, and the first one tomorrow. So again, these are categories well, these tests are dealing with categories. And so the goodness of fit really only deals with one category. And this one basically is saying, do we have an equality going on here? And specifically between our observed values and the expected. So that's really what we're looking for in the goodness of fit test. The second one, the homogeneity. So we know that that prefix homo means the same. So we're looking for similarity between 2 things. So here we're looking at 2 or more groups in the same category. So if we're looking at right-handed people and left-handed people, do they have the same interest in maybe a particular subject? So I want to see tests for similarity between math majors who are right-handed and left-handed. And then lastly, the chi-square test for association or independence. This is whether 2 categorical variables are independent based on one group of individuals. So if I take one group of individuals, let's say the students in my AP Stats class, and I measure their hand length and their foot length, are they independent of each other? Or do they have some sort of relationship going on between those? So again, we'll take a look at each of those later this week and dive into how to tell when we're doing each test.